Hey everyone, Geek37 back for another video, and this is part 25 in my Exploring the Heptagonal Triangle series. And in this video, what we're going to do is derive one more of these doubling identities. We add three of them together and we get a specific value. And in this case, we will be doing the cosines this time. So we got the cosine of 2 times pi over 7 plus the cosine of 2 times 2 pi over 7 plus cosine of 2 times 4 pi over 7. So what we'll do first is we will reduce these to see what we actually have. We'll have the cosine of 2 pi over 7 plus the cosine of 4 pi over 7. Oops. Sometimes my writing's not the best. It's a little better. Plus the cosine of 8 pi over 7. Now, in my last video, I explained that the sine of 8 pi over 7 landed it in the third quadrant, therefore it's negative. The same is true for cosine because both the sine and the cosine ratios in the third quadrant are negative. The only one that's positive is tangent. So we got the cosine of pi over 7 plus the cosine of 4 pi over 7 minus the cosine of pi over 7. Now the thing is, when you do a trigonometric ratio, they typically keep the value between 0 and pi over 2, and since pi over 7 is between 0 and pi over 2, it is the reference angle in the third quadrant, and since again cosine is negative, that's why we have minus cosine of pi over 7, and remember that 8 pi over 7 is pi plus pi over 7, hence why we have that specific ratio. Now, in one of my previous videos, I derived where these came from. This was c over 2b. Cosine of 4 pi over 7, that's obtuse. It's in the second quadrant, and cosine is also negative there, so that was b minus a over 2c. So minus b over 2a for the cosine of pi over 7. And you'll notice here that we have single variables in the numerator. That means they're all 1c, 1a, and 1b. We can factor that. We can factor out the invisible 1. And you'll notice the 2 in the denominators, 2b, 2c, and 2a. We can factor out the 2. So what we have is we are factoring out a fraction of 1/2, just like so there. So we have c over b minus a over c minus b over a. And what I'm going to do is I'm going to find the common denominator for the first two fractions, first two ratios. So c squared minus ab. So the common denominator is bc. So we cross multiply c squared and ab minus ba there. We'll scooch on up here. So that will equal 1/2. Now remember, c squared minus ab is a Ptolemean identity, and what that reduces to is b squared. I derived that in one of my first videos. So b squared over bc minus b over a. And the nice thing is one of the b's cancel on top and the b cancels on the bottom. So we're left with b over c minus b over a. So here's what will happen. We'll get AB on the top minus BC. Common denominator is AC, so we cross multiply to get that AB and that BC. Now you'll notice here that AB minus BC is itself a rearrangement of a Ptolemean identity, namely AB plus AB plus AC equals BC. I derived that in a previous video. So if you wanted to work out the algebra on that, you would wind up with the numerator of negative AC over positive AC. And of course, since they are the same amount but with different signs, this will reduce down to negative 1, just like so there. And I'm sorry, that should not be a negative in front of that 1/2. So what we're left with here is 1/2 times negative 1. That'll equal negative 1/2. So our doubling cosine identity, cosine of 2 times pi over 7 plus cosine of 2 times 2 pi over 7 plus cosine of 2 times 4 pi over 7 equals -1/2. All right, so far that will conclude the doubling identity portion of this series and this playlist, and I wanted to show that to you today. All right, I hope you enjoyed this video. I enjoyed making it. This is Geek37 signing off.